Hello, my name is Rob Reynolds, and this is section 1.2 of college algebra. And today we're going to be discussing quadratic equations. Quadratic equations are a little bit different than linear equations that graph a line. Quadratic equations have an x squared term, and they look like this parabola. This is the shape of your parabolic functions. So we're going to talk about the values of a, b, and c just a little bit later. When you're solving a quadratic equation, you want to think about factoring it and setting each factor equal to 0. So the GCF here would be x. So we're going to factor out an x and then set each factor equal to 0. So either x will equal 0 or x will equal 4. We also want to check for any extraneous solutions. What that means is if you were to graph this parabola, it would cross here at 0 and it would cross here at 4. Since the value of a is positive, it would also be facing upward. But you're going to be looking at this because we're going to be using your graphing calculators today to be identifying those roots or those zeros or those solutions. 3 words for the same thing. If it's not already set equal to 0, your first step is to set it equal to 0. You could subtract the x squared off, but that would make it a negative x squared term. My recommendation is let x squared be positive. So even though it's more work, I would bring the x term over to the left and the 6 over to the left as well. The next thing I'd try to do is try to factor, finding factors of 6 that differ by 1. I think we're going to be using 2's and 3's. Signs are going to be different. That's what this says. The larger term is positive, so I'll put a plus here and a minus here, and then go ahead and set each factor equal to 0. So either x equals 2 or x equals negative 3. Again, checking for any extraneous solutions. And when I say extraneous, I'm looking for anything that would cause me to divide by 0 or take the square root of a negative. To undo square roots, we want to square. Well, to undo squaring, we're going to take the square root. For example, we know that 2 squared is 4. And if you take the square root of 4, we're back to 2. And 3 squared is 9. But if you take the square root of 9, we're back to 3. So I oftentimes say the square root of a cow squared is back to the cow. It doesn't matter what's underneath here. It doesn't matter if it's 3x plus 2. The square root of 3x plus 2 will be 3x, or the square root of 3x plus 2 squared will simply be 3x plus 2. All right, that equals 3x plus 2. There's one more thing here that you need to know, and it's down here. If you take the square root, then there are 2 answers. But if the square root's already given, then there's only one solution. I think I can bring that to life for you, because if I were to ask for the square root of 4, most of you would say 2, and the opposite of the square root of 4 is negative 2. But if I were to ask you what values of x can I square to get 4, most of you would say, oh, x is plus or minus 2, and that's because if you take the square root of both sides, remember, we should, if you write that square root sign, we should have 2 answers, plus or minus. So that's the difference. All right, so a couple examples here. Again, to undo squaring, we should try to take the square root, but if you write the square root sign, you have 2 answers. So leave it plus or minus 7. I don't like long stringy decimals, so just leave that solution. If you were to take the square root of this side, again, the square root of a cow squared is a cow, and this time the cow is x plus 3. So we're going to write down x plus 3 is equal to, and the square root of 9 is 3, or it's also negative 3. So there's 2 solutions here. So you have to remember, the square root of 9 could be the 3, or it could be the negative 3. So I'm going to write this down twice. I'm going to say x plus 3 is 3, or, that didn't work very good, x plus 3 is 3, or x plus 3 is negative 3. So it's kind of like there's 2 separate equations, because the square root of 9 could be 3, or it could be the opposite of 3. So subtracting off 3 here, we get 0. Subtracting off 3 here, we'll get negative 6. Again, checking for extraneous solutions. Next, I'm going to show you how to complete the square. Completing the square, the main deal for completing the square is taking half of the middle term and then squaring it. So half of 4 is 2, but 2 squared is back to 4. And so notice your final solution is, if we're going to add 4 to both sides, or add 4 to x squared plus 4x, we get x squared plus 4x plus 4, which can be factored to x plus 2 quantity squared. Let me try this one more time. Completing the square helps us solve. It's one of the forms that we're going to use to solve. So on your test, sometimes I say solve using completing the square. Sometimes I say solve the quadratic using the quadratic formula. So there's different methods that we're going to be using for solving. One method is completing the square. So to complete the square, we take half of the middle term. And the middle term is nothing more, if you remember, the middle term is this ax squared plus bx plus c. So the middle term is always this b term. So in this case, it's 12 down here. So half of 12 is 6, but 6 squared is 36. So 36 is actually what the value that we're going to be adding to this side of the equation. Actually, we're going to add it to both sides of the equation, but there isn't both sides of the equations here. So after you add 36 to both sides, we can factor. Factors of 36 that add up to 12 are x plus 6 and x plus 6, which you could write as x plus 6 squared. This will make more sense in just a moment, but what I wanted to point out to you was, notice that half of 6 is 3. So this quantity over here should have a 3 in it. Actually, this is a negative 6 over here, so half of negative 6 is this negative 3. Down here, it's a little bit trickier. The value of the b is 1, but half of 1 is 1/2. So although you have some complicated things that we're adding, notice that this is not complicated. In this quantity over here, we always just have half the middle term. So if the middle term is 1, notice that in this quantity we have half the middle term. That will help you, at least, I think. This is why this is working. Here's your first example. We can only complete the square if you have a leading coefficient of a 1. Right now, the leading coefficient is a 2. So you want the a value to be 1. In order to get the a value to be 1, there's two things. You could either factor out a 2, or you could divide both sides by 2. I'm going to choose to divide both sides by 2. This gives us x squared plus 3x minus 5/2. And please leave 5/2 5/2. Don't try to change it to 2.5 or a decimal. I like improper fractions here. So notice that the middle term now has changed. The middle term is no longer 6. My middle term now is 3. So half of 3 is, and I would not, again, go decimal form, half of 3 is nothing more than 3/2. And I would leave it 3/2. So I call it the star step. So if you want to see what's going on here, I'm going to take half of this middle term and then I'm going to square it. And when I square 3/2, I get 9/4. 9/4 is the number that I'm going to add to both sides. So in fact, sometimes it's easiest to get rid of this negative 5/2 on this side and kind of think about what I want to be adding to both sides. So I'm going to take this negative 5/2 because it's really not productive on this side, and I'm going to throw it over on the other side. So we can just get rid of that negative 5/2 and set ourselves up for completing the square. So I'm left with x squared plus 3x plus some number that I'm going to add to both sides is equal to 5/2 plus some number. Well, and I've already decided that the sum number is going to be 9/4. So we're going to add 9/4 to both sides. And this looks complicated over here, but really, if you remember the previous exercise, this is nothing more than factoring and figuring out that, oh, I don't need to find factors of 9/4 that add up to 3. I know that this will factor nicely, because that's what completing the square accomplishes for me. So I should know that this is going to factor to be half of that middle term. That's what I was trying to show you before on the other slide. So half of that middle term is 3/2. And this is going to be quantity squared. And then over here, I might want to think about this as being 10/4 plus 9/4, which will give us a total of 19/4 over here. Now remember, when you take the square root of both sides, we get two answers. So again, I'm going to have to remember this is going to become x plus 3/2 is equal to plus or minus 19/4. And the last step is to subtract off the 3/2. So x is equal to negative 3/2 plus or minus 19/4. Oftentimes you'll see that this can be written as x is equal to, oh, let's see, wait a minute. Now I forgot my square root sign here. So this is the square root of 19 over the square root of 4, which is negative 3 plus or minus the square root of 19. This is divided by 2. This is also divided by 2 because the square root of this 4 is this 2. And then the final solution here probably could be written as x is equal to negative 3 plus or minus the square root of 19, all divided by 2. So that was a long problem. But that gives you an idea of a good example of completing the square. The other thing I wanted to discuss before the end of this video is the quadratic formula. Some of you see that there's some songs for the YouTube videos. Some of you know how to sing it, "To Pop Goes the Weasel," but memorize negative b plus or minus the square root of b squared minus 4ac all divided by 2a. It's important for you also to know a piece of the discriminant, the b squared minus 4ac. If it's positive, if it's greater than 0, then you know that there are two solutions. And that's what this graph looks like. So if you take the square root of a positive answer, we get two solutions. This says if the discriminant b squared minus 4ac is 0, there will only be one solution. And this graph is the square root of a negative, which you know is an imaginary number, but that means that there are no solutions. And the graph of no solutions means it just never crosses the x-axis. So if I were to show you a quadratic formula, I would quickly identify a is 2, b is negative 4, and c is 1. So if I plug this in, I kind of like to think about this being the opposite of b. So the opposite of this negative 4 is 4, plus or minus the square root of b squared. Well, that's negative 4 squared, or 16. Minus 4 times a times c, all divided by 2 times this a value, or 2 times 2. So 4 plus or minus the square root of, let's see, 16 minus 8 is 8, all divided by 4. Now some of us are going to make a critical mistake here by canceling part of a sum, and I kind of get pissed off at students, P-O-A-S, pissed off at students when they start canceling part of a sum. So you can't do this in math. If it's a product, you can cancel, but if it's part of a sum, you can't. Now we can simplify the square root of 8, though. This is really the square root of 4 times the square root of 2, which you should know as the square root of 2 times 2. So if I were to rewrite this as 4 plus or minus 2 square roots of 2 divided by 2, and again, just explaining a little bit where I got that, the square root of 4 is this 2. So now I can cancel, not part of a sum, but I can cancel both sums. And then in this case, I'm left with 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, and I'm just left with the square root of 2. So that's a little bit difficult. On this one, I would probably multiply both sides by 2 first, just so I could have an easier value for a, b, and c. On this one, I would try to get all the values set equal to 0, so I can quickly identify the a, b, and the c. In this case, it's, again, 2x squared minus 2x plus 3. So there's my a term, there's the b term, and here comes the c term. On this one, I would probably multiply every term through by x squared before I try to identify the a, b, and the c term. For this one, I would probably use, if they say 144 cubic centimeters is for the volume, I'd plug it in, 144 cubic centimeters. I'd probably multiply this out, or I could do this on the calculator and guess left, guess right, guess on. But the important thing is to set this thing equal to 0, see if you can factor it, and find solutions. So that pretty much gives you an overall view of at least the first part of the quadratic formula.